Number representations in computing. In computing, numbers are represented in a way that a computer can understand and process. Computers use a binary system, which consists of only two digits, 0 and 1. Each digit in binary is called a bit. The way numbers are stored and processed in a computer can be categorized into two main types: fixed point and floating point representations. Hash fixed point representation. Fixed point representation is a way to store numbers with a fixed number of digits before and after the decimal point. This is similar to how we might write money, like 123.55, where the decimal is fixed in place. In this method, the position of the decimal point is predetermined, hence the term fixed. Fixed point numbers are commonly used in applications where the range of values is known and where precision is critical, such as financial calculations. Example: imagine a system that needs to store prices of products in a store, always to two decimal places. If the price of an item is 199.99 cents, it would be stored with a fixed decimal point, making calculations straightforward and predictable. Advantages: precision. Fixed point provides exact representation for fractions, which is important in financial and other precise applications. Speed. Operations on fixed point numbers are generally faster because the computer doesn't need to adjust the decimal point. Disadvantages. Limited range. Fixed point representation has a limited range of values it can represent. If the numbers are too large or too small, they cannot be stored correctly. Waste of space. If the full range of the fixed point is not used, it can waste memory space. Hash floating point representation. Floating point representation is more flexible than fixed point and is used to represent very large or very small numbers, as well as fractions. In floating point, the position of the decimal point can float. That is, it can be placed anywhere relative to the significant digits of the number. This makes it possible to represent a wider range of values. A floating point number consists of three parts. One, sign bit, determines if the number is positive or negative. 2, exponent, represents the power of the base, usually 2 in binary. 3, mantissa, or significand, contains the significant digits of the number. Example: consider the scientific notation 2.5 times 10 to the 3, which is 2500. Here, 2.5 is the mantissa and 3 is the exponent. In a similar way, floating point numbers are stored in computers, but using base 2 instead of base 10. Advantages: wide range. Floating point can represent very large and very small numbers, making it ideal for scientific calculations. Flexibility. The floating decimal allows for greater precision over a wide range of values. Disadvantages. Precision issues. Floating point arithmetic can introduce small errors, especially when dealing with very large or very small numbers. These errors can accumulate in complex calculations. Complexity. Operations on floating point numbers are more complex and can be slower compared to fixed point arithmetic. Real-life use cases. Fixed point. In a cash register system, prices are stored using fixed point representation. This ensures that when adding up prices or calculating change, the results are exact without rounding errors. Floating. In scientific simulations, like weather modeling or physics simulations, floating point arithmetic is essential. It allows computers to handle extremely large ranges of values, such as the speed of light or the mass of tiny particles, and perform accurate calculations. Computer arithmetic. Computer arithmetic refers to how a computer performs calculations using these number representations. The two primary operations involve: 1, fixed point arithmetic. This is straightforward because the decimal point is fixed, allowing the computer to add, subtract, multiply, or divide numbers directly, similar to how we do it on paper. 2, floating point arithmetic. This involves more steps. The computer has to align the decimal points by adjusting the exponents, perform the operation on the mantisses, and then normalize the result by adjusting the exponent again. Handling errors in computer arithmetic. Rounding errors. When performing arithmetic with floating point numbers, the result might need to be rounded to fit within the available number of bits. This can lead to small inaccuracies. Overflow and underflow. In fixed point representation, if a number is too large to be represented, it causes an overflow error. Conversely, in floating point representation, if a number is too small to be represented, it causes an underflow error. Computers have methods to detect and handle these situations, but they can still lead to problems in calculations. Summary. Number representation and computer arithmetic are fundamental to how computers process and store data. Fixed point is used where precision is crucial and the range of numbers is limited. Floating point is used for a wider range of numbers, especially in scientific and engineering applications, but it comes with the trade-off of possible precision errors. Understanding these concepts is essential for designing systems that require accurate and reliable numerical calculations.